That is incorrect.
And then I did that.
You used to be my favorite teacher.
Until he got.
He used to be my favorite student.
Oh! You used to be my favorite teacher. Who's your favorite student now? Who is it?
Alright, so what we're going to do today, we're going to talk about kind of some history of how the periodic table came about. We're going to talk about three dudes. Okay? These are the three most important guys that were probably influential in discovering or coming up with our modern periodic table. Okay? So way back in the early 1800s, there was like no order to the elements that they had discovered. They had no way of organizing them in any meaningful manner. Far from where we are today. I'm sorry, I can get your new one if you want.
You fix the X.
Why?
You could just roll it with
Roll it
your
with
pen.
Mark
But no, it's just small.
Make it bigger. So we start way back when, 1800s, when we had come up with elements. We had gone through Aristotle and what he was ludicrously known for. What was his contribution to the periodic table and elements? Fire, wind, earth, and water. Okay? Then along came a skeptical chemist. Who was that? Uh-oh. I already got the people. We're messing up on the people. Look at your vocab, please. Let's think
I
things.
was right, it was boiled.
You never said it on here.
Sorry. Boiled that I thought.
She thought
I'm not loud.
You don't Tokyo.
Yell.
Robert Boyle.
Robert Boyle. Okay, he wrote The Skeptical Chemist, which basically said you can break up these things into smaller things. And then along came the French guy who actually did it.
Antonio.
Yeah, and Antoine Lavoisier.
Antonio Lobos. Antonio Lobbies or else. I thought it was.
Okay, Antonio Lavoisier. Okay, what did he break apart?
Water.
When that shattered, what Aristotle said, yeah?
Yeah.
Okay, so they had finally come up with a small list of elements. Okay, but their elements didn't have any, there was no relationship between them. They hadn't organized anything in a way that was meaningful. Okay, it wasn't until Mr. Johann Dobreiner.
Oh, wow.
It's a Dobreiner, guys.
Whoa. What'd you say?
It's a Dobreiner.
No-brainer?
How do you pronounce that word?
It's a no-brainer. It's a no-brainer.
It's kind of anything.
Wow. How do you pronounce that?
Wow.
What
is the two dots over the O called?
What was that?
What are the two dots over the O? Yeah, the two dots.
It's German.
Okay.
How do you pronounce it?
I always.
No-brainer.
No-brainer like dots.
Is it
I have no idea. That's just how I pronounce it.
No-brainer.
Joe-brainer.
Joe-brainer. No.
Somebody asked Siri.
Siri, how do you pronounce it? Dobreiner.
I'm not kidding.
Johannes. It's actually, I think his name is Johannes.
How the heck is that?
Johannes Dobreiner. Schweinsteiger.
9.
German. Schweinsteiger. Like Kramer. I'm mostly German. I'm like 100% German.
Wow.
I'm not.
My great grandma was pure German.
Yeah,
That was it.
Yeah, my grandmother was pure German. My mother, she
I'm
spoke
German.
German.
As Abby says.
guys, when it comes to periodic table, and who helped discover the periodic table, it's a Delbrader. Okay, so really what Mr. Delbrader, Johannes, what he did that was so significant for our discovery of the periodic table of elements is he noticed that there were certain elements that acted very similarly. And what do you think he was doing? I really hope that one of us can at least get there. Based on what we know determines chemical and physical properties, what do you think he was doing when he figured out certain things that acted very similar? What do you think he was doing? How did he arrange them? What was the kicker in how he arranged guys so that they acted similarly? What? No. Okay, what determines properties? What kind of electron? Valence electrons. And so what he started to do is he started to see that when he arranged guys based on how they acted similarly in their chemical and physical properties, he noticed that they had similar valence electrons. So his first triad, his first group of three that he noticed had very similar chemical and physical properties was this. Actually, this was his first triad. It was the three halogens here, chlorine, chlorine, bromine. All very colorful, all very reactive, a lot of similar chemical and physical properties. And the reason why they had similar chemical and physical properties was why? Same number of valence electrons. And we know that the valence electrons are the ones that determine the properties because they're the ones that are involved in bonding. Okay? Interesting. Okay? This is Dahlgrenger's first triad right here. Chlorine, bromine, and iodine. I don't know if you can see here. This should also help us with the colors up here and what they represent. What does the red represent? Gas at room temperature. Okay, so chlorine's a gas. If you look closely, do you see how it's like yellow gas? I don't know if you guys can see back there, but if you look closely, you can see the yellow tinted gas. Can you see that?
He could.
What's so funny?
Yellow
gas.
laughing because you said yellow gas. Not
How
yellow.
immature the tinted.
Okay.
Wow.
Gas.
Then we got bromine here,
Bro.
which is a what at room temperature? And then we have iodine. It's actually really cool. It's purple. And actually, if you get it on your skin, it turns your skin orange.
Oh my gosh.
So, like, I think that's what Donald Trump did. He just,
Yeah. Amen.
Is it like?
oh, snap! Okay.
Honey babes.
Is it really bad though? Like, if
Zing! All right.
Campbell 2017.
Let's go. Kramer for president. 20, whatever. 2021.
Donald Trump.
What was that? Okay, so Dahlgrenger, he started to arrange them based on their properties, noticed that things acted very similar, and we know it was the result of valence electrons. But then came along the guy, what?
E?
We just jumped.
That's because I threw out three guys that I didn't think were very important.
Oh, okay, so let's just replace that one.
Yeah, you can replace that with a C if you would like. That would make logical sense.
That's a no-brainer.
That is the Dahlgrenger. Johannes, that is Dahlgrenger.
Wow.
You are German. What do you?
I'm very German. Schweinsteiger.
Is the only German word you know to say is Schweinsteiger?
It's not. That's well.
It's not even.
Yeah.
Yeah.
I can't lie. My dad knows a few other German words, like, I don't know.
Wow.
Like,
Mine does like that. All I need to
you just like make weird noises with your mouth with some German words. Like, it's a German word. It means like, hi.
Makes a lot of sense.
How you doing?
Welcome is an easy one.
What?
Your name,
Oh
German.
yeah,
What is it?
Say
Danke.
hi. It's our welcome.
Welcome in.
Welcome in.
Welcome in.
Thank you is Danke.
Donka.
Not the white.
Donka. Tom.
I was German in a play one time. That's why I know that.
Ah.
Really say that.
I say Danke a lot for
Alright.
no reason.
Here we go, keep going. So, Mendelov developed his periodic table using 4 techniques. Now, I want you to write somewhere next to Mr. Mendelov that he is credited with discovering the periodic table. I want you to write somewhere. He is credited with discovering the periodic table. Now, his periodic table is not 100% identical to the periodic table we have today, but he's the one that's given credit for it. And I'll explain why when we start talking about the 4 things he used when doing his list or his table of elements. There's his first 2. Here's how he arranged it. Here's some things he did.
Yeah.
The what?
I'm gonna have to get my chemicals together. Yeah, I forgot about that. It's a little tedious process. You're gonna have to bear with me. Yeah, I'll make it happen.
At least it's better than ACA. According to my friend, they literally do labs every other day, and one time they had to sit and watch ice melt. They had to sit and watch ice.
You know, I think there's a healthy, labs are good, but from my experience, most of the time kids don't really engage in the labs, they just engage in the wow. They can't really connect what's going on with what's actually happening. Because they're just like, they just want to do something fun. Because it's fun to like touch a chemical and die. Like,
It's so cool.
But no, it's like the lab manual kind of thing, where it's a page in that lab manual thing, where they have to do that, and then answers.
well, that's okay. That's not always bad.
Let's watch ice melt. I hated those. Wow. And I'm so glad that I don't get them. Okay.
Okay, so I'm gonna have you get the other 2 in, and then we're gonna talk about why he's credited with coming up with the periodic table. Once you've got this in, I want you to open up your books. I'll tell you in a second. That shows right on the board. Once you're done, open up your books. That's the marker. Turn to page 390. You can see Mr. Dmitri Mendelov. There's no picture of Dobrainer. I guess it's a Dobrainer, what he looks like. Oh, that never gets old. Oh, so much Okay, 390.
Oh, wait.
Is that Dobrainer?
No, this is a cartoon, but it can be if you want.
Oh,
Who's that?
that's weird.
You wouldn't have had the wrong element because
Probably Julio.
Yeah, I don't know. Oops, wrong element. I just blew out. Fun experiment.
oh no, I did CA instead of CM.
why he's really credited with his periodic table. Is he started to list the elements that he knew. He started to organize them, and I think in A, this is how he organized them. Okay, he organized them or arranged them in a list based on atomic mass. Okay? And if you remember, atomic mass is this number up there. We'll talk much more about that when you take chemistry. Okay? And notice he left blanks. Now, let's look at this. Okay? There's a blank between calcium and titanium. There's a couple blanks between zinc and arsenic. Everybody see the blanks there? What he noticed is approximately there was a new element every couple atomic mass units. And he looked and he said, there's 10 atomic mass unit difference between zinc and arsenic. So 65 and 75. And he said, I bet that there has to be some unknown elements that have not been discovered yet. And he left blanks for them. What's funny is he has 2 gaps in between zinc and arsenic. What did we later find out?
There were 2 spots.
There were actually 2 unknown elements that were yet to be discovered. And he predicted it.
Whoa.
And not only did he predict it, but he arranged his periodic table in columns that he said this unknown element here is going to have very similar properties to aluminum and boron based on what column they're in. Or in this case, it looks like they're in horizontal rows. So look, the first blank after zinc would be under boron and aluminum if you were looking at the horizontal column that he would have. You see it? Yeah, if you go left of that first blank, you see aluminum and you see boron. And actually what was funny is somebody discovered gallium and he said, here's the properties of gallium, it disproves your system. And he goes, no, that can't be right. These are what the properties should be like. Gallium should act like this, 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 and this. And the guy's like, no, that's not what I see. Turns out the guy was an idiot and couldn't even correctly analyze the properties of the thing he had in front of him. And Mendelov correctly predicted the properties without even having it in front of him. Yeah, he's like, duh, I learned from Mr. Dobrainer. It's a Dobrainer. Okay, that wasn't it.
Such a knee slapper.
Okay, so he placed elements with similar properties in columns, and he actually, not only did he predict the unknown element, but he also pretty closely or pretty accurately predicted the properties that they would have, which you can understand why this guy's probably given credit for discovering the periodic table. I mean, that's pretty good experimental work, if you ask me. Okay? However, there was one problem with Mr. Mendelov's periodic table.
Oh. Dang, so good.
He pretty much correctly predicted everything except for a few things, and the thing that was wrong with his periodic table is that he didn't arrange his elements correctly by arranging them by atomic mass. Now, is this a huge deal? Not as big of a deal. No, I think it's a relatively small goof, but enough to still give him credit for the periodic table. That is an I, yep. Selenium and iodine. So I want you guys to realize here that Mendelov, at that point, he was just arranging this periodic table. He had no idea what a valence electron was. Okay? It wasn't until later that we identified the reason why things have similar chemical and physical properties and in their vertical columns act very similarly is because they have the same number of valence electrons. But here's what was wrong with his. He arranged, remember how did he arrange his list? What did he arrange it by? Atomic mass. Okay? Our current periodic table is not arranged by atomic mass. How is our current periodic table arranged? Do you know? By atomic number. Okay? And believe it or not, when you arrange it by atomic mass, you get a couple elements that actually get out of order. Selenium and iodine are the two of probably the ones that we look at the most. There's a couple other guys. But if you look, iodine actually is less massive than selenium. Everybody see that? Okay? But iodine has one more proton. Alright, let's see if you can get this from last chapter. Why would iodine have less mass even though it has one more proton? No, because doesn't this have also 53 electrons then? If it's a neutral atom? Iodine's isotopes actually have less neutrons than selenium. Therefore, selenium actually weighs more even though it has one less proton and one less electron. Okay, there's a few other guys that are like this. And so if you take these guys and you flip them based on their atomic mass, wouldn't their valence electrons be out of whack? Because this guy has 7 valence electrons, this guy has 6, and if you flip them, do you see how their properties wouldn't match up? Iodine doesn't act like these guys, and selenium doesn't act like these guys. But if you arrange it by atomic number, it also properly arranges them by their valence electrons as well. Okay? So, is this a big goof? I don't think so. I mean, it really only knocked a couple guys out of whack. You broke Carly's pencil?
It's okay.
It happens.
It's okay.
Okay, so here's what it's showing you. If you have a mass order, it's going to flip them if you do it by atomic number. All right, last dude of the day. For the bears. Mosley. I mean, it's just Mosley, but like, you know, it kind of sounds like Mosley. That one's not bad. I just couldn't think of anything else. So Mosley actually came up with a way to count the number of protons in the nucleus, which was kind of cool, pretty big finding. And when he counted the number of protons in the nucleus, he realized that the proper way to arrange the list of periodic elements was actually by atomic number. So who's given credit for coming up with the periodic table? Mendelov, even though it was Mosley who correctly arranged it how? By atomic number. So we have our periodic tables currently arranged by the number of protons. Uh-oh. So he just made this little correction, and now all of the chemical and physical properties got aligned how they should be. Nothing was out of order based on their chemical and physical properties. Right, Mari?
Right.
Alright, okay. Hey, you're still writing there, aren't you? Got it? Alright, who developed the periodic table?
Mendeleev.
Who is the first to group similar elements together?
No-brainer.
It's a no-brainer, guys.
Labrador.
All right, don't yell this out loud. Just think. Who changed the order of the periodic table to atomic number?
I know this.
Mari?
Number 2.
Mosley. Last one. Little vocab word here. Periodic law. You guys know what periodic means? What does it mean? Anybody? What does periodic mean? Okay. It actually means repeatable.
Oh, Ethan's shirt says I wear this shirt periodic.
Yeah, because it's repeatably. So periodic means repeatable, and it makes sense. The elements are arranged in a very repeatable fashion. You get guys that have the very similar chemical and physical properties based on their repeatable pattern.
That was the last slide, right?
There might be a couple questions, but nothing that you have to write in. So periodic law just says that the properties of the elements on the periodic table, if you arrange them by their atomic number, they have a very repeatable way to them. Don't leave. The bell's not going to ring till 12:50 or 11:50 anyways.
You just left early.